All right, so we're back. So we're gonna move forward now, and we're gonna look into the ways into how do we do our correlation matrix, and we're gonna do also our structural equation modeling using only direct effects for this video. So let's get to it. Now I'm going to introduce to you to another piece of like another tool that we're gonna use for the purpose of this session. So let me introduce to you the Stat Tools package. This was created by Professor James Gaskin, and he has a YouTube channel. It's James Gaskin at YouTube, and he's got a lot of great videos regarding structural equation modeling, doing measurement models and structural models, both in AMOS and in PLS, like partial least squares. Growing up and doing my PhD program and all, and when I stumbled on this, it made things a whole lot easier for me to do my own analysis as far as using SEM is concerned. So shout out to Professor Gaskin. Thank you so much for uh, for sharing such wonderful tools with us here. This is available on his website. It is in his YouTube channel. The website for that one. No, and yeah. So let's get to it. So we're gonna use the correlations table and the standardized regression weights table that we get from the AMOS output. We see here it's on the estimates tab part here. So we're gonna use the standard the first of all we're gonna use the correlations table. We just copy that and we paste it on A1 as said in these instructions here. And then we're gonna use the standardized regression weights table so that we can do it like F1 here and then click on this button so that we can run it. All right, so this is now our correlation matrix. Okay, so what does this tell us? So you will notice that there are new numbers that we're seeing here as well. Uh, the CR that we're seeing here is the equivalent of our reliability or our Cronbach alpha here. And then the AVE, the average variance extracted, is probably our equivalent to our total variance extracted or total cumulative variance that we did with SPSS. We're more interested with these two columns here. The MSV and ASV are additional validity numbers that we use for that one. So the CR is equivalent to our Cronbach alpha. Normally, what I also do is like I report this and then the Cronbach alpha. So all you need to do is to go back to SPSS, do your Cronbach alpha there, but this time again using the items that you kept after the factor analysis. So for let's say if I'm gonna run my Cronbach alpha using TRE for trust in e-government, I'll only be using TRE1 and TRE2. And then for the Cronbach alpha for information quality, I will be only using IQ 2, 3, 4, 4, IQ 2, 4, 5, and 6. So yeah, and just do the same thing. So you get your Cronbach alpha there. You can probably also get the same, like you can also do the same thing for your total cumulative variance, but you just want to run factor analysis again using this one. But the AVE is a very good indicator as well that would, yeah, it would substitute for your total variance extracted. Normally, when you use CR and AVE as the reliability and discriminant validity numbers here, it will already tell your audience that you've been using structural equation modeling for your analysis. Now the next part that you see here is like okay, let me like say for this one for better presentation. All right, so the next part here is you see is this is your correlation matrix. Now you notice that instead of 1 here, you will see another number, and this is actually the square root of your AVE. So this is a different way for you to interpreting it. Now, what's good about this Stat Wiki Tools thing as well is that so the Stat Tool package is that it already highlights you some of the problems that you see that with regard to the discriminant validity or convergent validity of your numbers, of your results. So you can see here that let's say for instance, the system quality, the square root of the ABE here is highlighted in red because that means that there's a number that is greater than the square root of the ABE, and this is here, surf qual. What you want is that these square roots, the one in the diagonal, the square root of the ABE in the diagonal is greater than the correlation numbers on the other variables that the variable interest is correlating to. Otherwise, you may run that there is some discriminant validity problems there. That means it's like the way that we look into the correlation matrix in SPSS. You want the question items to measure more the variable that they are in. So if you see something like this, and that means there might be some items that are uh, problematic in the way that they measure them. So in this case, if you see something like this, normally what you want to do is you go back to your factor analysis, delete some more items or modify some more items, and get an improvement on this one. But for the purposes of this exercise, I'm going to leave it as is. Sometimes what you also do is like you may have some practical reasons why there's this problem, and for academic research, it's always a case of trying to explain it properly why the phenomenon exists, especially if you've exhausted all of the options already that you have available for you. So yeah, so let me just repeat that. So when you do report, okay, what you want to report are these, the CR and the AB values, and then this table. That's the one that you're always looking for. All right, so okay, I'm gonna click reset so that I can just have everything back here. I'm gonna close this now, and don't save. Okay, you don't want to save this one. It's gonna ruin everything. All right, and then we're gonna go straight now to doing our regression model, our SEM. So let's go back to our model here. I'm gonna save it as a different file, so that's not try not to mess it up. So I'm going to save it as okay, SEM AMOS SEM direct effects. Okay. All right. So we're now there. So we're going to now I'm going to demonstrate to you now how to use AMOS to do our regression using direct effects. So I'm going to erase all of the covariances, these two-headed arrows that you see here. Now again, be very careful because as you can see, there's some overlap. You might accidentally erase something that you don't want. So as long as you see it turns red, that means it's selected. So you hover your cursor over it, and if it turns red, that means it's the one you're ready to delete. So right, okay. Now based on our model here, okay, like I said, we're gonna do direct effect first. So I'm not gonna touch first on trust in e-government here. So I'm going to delete trust in e-government for now, because we're not going to do moderating effects. We're gonna do that in another video. So okay, so I'm gonna go back here. I'm going to take away trust. So I'm gonna see you later. Okay, so we're left with these for now. Now, what we want to do is, again, we want to preserve the symmetry and move it around so that our model here would correspond to the model that we have in our Word file that I just showed you a while ago. So let me move this around. Perceive it's going to be here. User satisfaction is going to be here, and it's here. So okay. Now this is the beauty of AMOS, because you can visualize how your model is going to look at. You can do analysis here. You can visualize how it looks like, and it's picture says 1,000 words, so that's fine. So I'm going to rotate this a bit. Okay, yeah, that probably is fine. All right, and then this, no, okay, there you go. So that's it. So I'm going to move this here, so that's gonna be a little bit, just a little bit neater and all. All right, now we're going to follow what our model says here, like our proposed model says here. So what we're gonna do is we're gonna use this draw paths. So we're gonna draw paths now, info quality to perceive usefulness and user satisfaction. system quality to perceive usefulness and user satisfaction, serves quality, and so. And then go so just to make sure that we're doing it properly. All right, the next three that we're gonna see here, we're gonna also reflect this one. Is okay, we're gonna do this here, and then this two here. All right, so so if you notice now the way we drew it here, it's very similar to our model that we're showing here. All right, so and then next part is we're gonna use, okay, we're gonna add a unique variable to an existing variable here. Here, we're gonna only put that on what we see as the dependent variable. So anything that a path goes into. So we're gonna see more. Like, yeah, we're gonna have this here. Okay, and then name unobserved variable so that you can see that there. And then we're going to select these three and then covariate them together. Okay, like these are our ultimate independent variables. We're gonna covariate them together here. Okay, and then, right now, like some would argue the merits of covarying independent variables. Normally, this is like just to improve model fit. Practically speaking, this is gonna be improving your model fit. But of course, you also want to reflect the realization that like sometimes your independent variables are working together so that they can influence your dependent variables. And this is what actually it means. Like you're going to run regression on all of this at the same time. Like all of these paths here that you're seeing, these are all regression paths. So we're gonna run it all in the same time here. Okay, so we're gonna all right. Let's go to analysis properties first. We're going to add some functions here that we're gonna see. So we're gonna go for squared multiple correlations, direct and total effects. Yes, and then yeah, comparison correlation estimates, critical ratios for differences. Yeah, that's something that I would also want to see there. So it's minimization history, standard estimates, squared multiple correlations, modification indices, direct and total effects, covariances, correlations, critical ratios for differences. All right, that's the thing. Those are the things that you need for your SEM model. Now, one thing I would like to say before we would continue, since we already did the factor analysis and we all this modification indices and deleting, I'm hoping that we would do very little when it comes to further doing modification indices and deleting items. Just because the assumption is that we already took care of all of that during the factor analysis. So we're just running regression here. So we're not going to do anything else. So I'm going to save. And afterwards, let's run and pray that this works. All right, so okay, so it works. So we got a chi-square here of 614.9 here, and then let's go to our results. So again, the first thing that we're gonna look, well, this time the first thing we're gonna look into is the model fit, because this is like the model fit. So see, we got similar numbers. RMR is a little bit higher. It was 0.04 during our factor analysis. It now is up to 0.05. That's still fine. But of course, like I said, what's more important is the GFI and AGFI here. So we're 0.913, 0.88. That's fine. Our baseline comparisons of NFI, TLI, and CFI, 0.96, 0.97, 0.98. We're still good. Our MSCA is less than 0.08. So yeah, so when you're doing your regression analysis, your structural equation model, here the first thing that you look into is your model fit. Right? Your model fit. Now we're gonna go to the estimates. All right. Now the estimates, okay, you're gonna see the first thing here. This is again the unstandardized weights. So these are the unstandardized weights. But what we want to see here are the CR values. This is equivalent to your T value. So the threshold here is 1.96. or this one. This is the only thing that we're going to look into. I'm going to highlight it so that you can see that what, whoops, sorry. Yeah, this is the ones that we're going to, because these are now your hypothesized relationships. Like these are the ones that we ran regression for. So, and then, so the CR values, okay, the CR values and the P values would tell us which ones are significant or which hypotheses are supported. So we're going to see here that in our case, the CR again, CR will be great, should be greater than 1.96, and p-value should be less than 0.05 if we want to say that that relationship is significant. So we're gonna so we see here that info qual to perceived usefulness is significant, system quality as well, but service quality to perceived usefulness is not significant. You got a low CR value here and a high p-value here. So yeah, and then the same thing for system quality to user satisfaction. You see here that it's 0.261 p-value, that's greater than 0.05, and 1.125, that's lower than 0.196. So this one is not supported. And then the rest are all supported. So you're going to report these values here, the CR and the p-value, but the estimates, as far as you're concerned, you're going to look at the standardized ones that you see here below. Right, so these are the ones I'm gonna report. That these standardized weights are the ones you're going to report here. These are your betas. Okay, these are your betas. But in terms of the T value or the CR value and the P value, you get it from here. All right. Now there's actually a way for you to also see it in your in your actual drawing. You want to click on this view the output path diagram button here, and you will see all of these values. And you see all of these values here, but you want to look also into the standardized estimate. So you can see that in these paths that you see here, these would correspond to the tables that I've just shown you earlier. Okay. So yeah, so this is the way that we're going to run regression for direct effects. So yeah. Okay. So and again, since we did already a lot of the work we already did in the factor analysis part, this confronting factor analysis part. So all you need to do is to run the regression as is, and ideally you would do very little when it comes to what else that needs to be done in order to improve model fit and all. Oh, one more thing. Yeah, speaking of model fit, I think I forgot to mention one thing. It's supposed to be here in your yeah, supposed to be, yeah, the squared multiple correlations. There you go. In the squared multiple correlations, you can see here you can see three variables here. Like if you notice, these are the three like dependent variables in your model here. These are the three independent variables, and these are the two independent variables. But these two variables are the independent variables to this dependent variable. So this squared multiple correlations that you're seeing here are the equivalent to the R squared, or in the adjusted R squared. So perceived usefulness here, and with these three, you got an R square of 0.81. Okay, it sees there, so it's 0.81 there. User satisfaction, you get an R square here of 0.88. 0.88. And then for the perceived benefits here, you get an R square of 0.88 here, or 0.878 here. So yeah, so this is the other figure that you can also include in your model fit figures that you would report for your structural equation model. Okay. All right, so that's okay, so pretty much that's it. On the next videos, I'm going to show you how to do moderating and mediating effects using both SPSS and AMOS. So yeah, I'll see you next time.